Hey everyone, and welcome. If you're here with us, I'm guessing you're as fascinated by the future of tech as I am.
It's a pretty amazing time to be following these technologies.
It really is. And today we're diving deep into something that sounds like it's straight out of sci-fi. A research paper called Advanced Architectures, integrated with Agentic AI for next-generation wireless networks.
Catchy title, right?
Totally.
Yeah.
So, what we're really trying to understand here is how 6G networks are going to be completely different and how AI is going to play this mind-blowing role.
AI is really the core of this whole thing.
Yeah. Like, imagine your AI managing your network connection, like in real time, constantly optimizing for speed and energy use, maybe even security, all while you're, I don't know, streaming a movie or something.
That's the vision, yeah.
Okay, so, I mean, we all know 5G is crazy fast, but what are the limitations? This paper talks about those, right? Even with new frameworks like HexX.
Yeah, they do. 5G is based on what's called a service-based architecture, and it's pretty complex, even with these latest advancements. This paper is proposing a new approach for 6G, separating the control and user planes using AI.
Okay, back up for a second. What does that even mean, control and user planes?
Basically, think of it as two different layers of the network. The control plane is like the brains of the operation, making decisions about how data flows, and the user plane is where the actual data transmission happens.
Got it. So in 6G, they want to separate these two layers. But how does AI fit into all of this?
AI acts as this super smart manager between the two, making sure everything runs smoothly and efficiently. It's like having an air traffic controller for your data, making sure everything flows smoothly and efficiently.
Ah, I see. So instead of like one giant control tower, we're talking about a network of smaller, more agile controllers powered by AI.
Exactly. And these controllers are using what's called agentic AI, which is basically AI that can make decisions on its own in real time, adapting to the ever-changing conditions of the network.
So it's like each device has its own tiny but powerful AI brain, constantly making sure it's connected in the best way possible.
Exactly. So your phone might know when to switch from Wi-Fi to cellular to save battery or prioritize video streaming for the best quality, stuff like that.
That's wild. But I mean, if all these AI agents are working nonstop, won't that just kill our batteries even faster?
That's a great question. And the authors of this paper actually address that head on. They talk about something called constrained AI operations, which means designing AI agents that are intelligent and incredibly energy efficient.
So these AI agents, they're like what, marathon runners? They can go the distance without breaking a sweat.
The paper doesn't get into the specifics of how exactly this energy efficiency is going to work in 6G, but we can look at some real world examples for clues. Google, for instance, they've used AI to cut down their data center's energy consumption by something like 15%. That's massive.
Yeah. And MIT, they used AI to reduce energy use during AI model training by like 80%. It's almost as if the AI is learning to be less power hungry.
Exactly. And those principles could potentially be applied to the world of 6G. Of course, that's going to be a huge challenge with data flying around all the time, but it's also a huge opportunity.
Okay, but with all this talk about AI, we can't forget about security. I mean, we're essentially handing over control of our network to these super smart AI agents, right?
You're right to be thinking about that. The paper does highlight some potential vulnerabilities. They specifically talk about attacks like model inversion, poisoning, and membership inference.
Those sound pretty intense. What do those even mean?
Well, model inversion is where attackers try to reverse engineer the AI model to extract sensitive information. Poisoning involves injecting bad data to corrupt the AI's decision-making process.
Okay, so hackers could basically trick an AI agent into like leaking data or messing up the entire network.
Yeah, that's the concern. The authors suggest a few ways to tackle this, like designing the AI agents with security built into their core, make them resilient to those attacks while still keeping them energy efficient.
So it's like a delicate balancing act.
Mm.
Super smart, secure, and energy efficient.
Absolutely. And finding that balance is one of the biggest challenges right now.
Okay, so we've got these AI agents managing the network, keeping it secure, everything's running smoothly.
Hmm.
What else is in store for us in this 6G future?
Well, this is where things get even more interesting. The paper talks about something called real-time serverless computing, and specifically using function as a service, or phase.
Phase. I feel like I need a diagram to understand this.
Think of it like a food delivery app. You can order from a bunch of different restaurants, but all through one platform. Face is similar, but instead of food, you're ordering specific network functions.
Hold on, so I could be ordering Ultra-fast gaming from one provider and rock-solid security from another, all at the same time.
Exactly, you got it. And this lets you deploy all these lightweight, super scalable functions across the network, even at the edge, all in real time.
That sounds amazing, but is there a catch? Is my network function delivery going to get stuck in traffic?
Well, one challenge is something called the cold start problem.
Cold start. Okay, what's that?
Imagine your food delivery app taking forever to load. That's kind of like the cold start problem with serverless computing. When a function is called for the first time, there can be a delay.
Oh, so there's a lag.
Yeah, and the paper mentions that this delay could be anywhere from a fraction of a second to several seconds, depending on the function and the network conditions. But AI agents can potentially help smooth things over.
Okay, so AI to the rescue, as usual. So how does all of this tie into the idea of a decentralized network, which we touched on earlier? I'm getting some real hive mind vibes here.
You're picking up on a key idea. The paper really emphasizes moving away from that traditional centralized network control and instead using autonomous cognitive agents. These agents would basically work together like a self-organizing system, like
Some
constantly
kind of
adapting to changes and working together seamlessly.
like a flock of birds or a colony of ants.
Yeah, kind of like that. They're all individually intelligent, but they also cooperate to achieve a common goal. The paper even suggests using those large language models, the LLMs, as part of these multi-agent systems.
LLMs, those things that can like write poetry and have conversations. What are they doing in a 6G network?
It might sound surprising, but they could play a big role. The challenge, though, is that they're very computationally demanding, but there are techniques like low-rank adapters, LoRa, and quantization that the authors suggest to get over those hurdles.
Wow, so we're talking about a network that's not just intelligent, but also incredibly adaptable and responsive, all thanks to AI.
Exactly.
This is pretty mind-blowing stuff. I think
Yeah.
we've covered a lot of ground in this first part of our deep dive. Before we move on, though, let's just recap what we've learned so far. What are the key takeaways here?
It's pretty clear, I think, that 6G isn't just about faster speeds. It's really a fundamental shift in how these networks are designed and operated. And AI, specifically agentic AI, is at the heart of that shift.
Yeah, exactly. We've talked about how these AI agents can optimize performance, make things more secure, and enable a more decentralized and resilient network.
Right, and it's not just theory. We have real-world examples that are proving this stuff actually works.
Okay, so our listeners are hopefully just as excited about this 6G future as we are. But before we jump into part two, I have one final question that's been bugging me. What are the wider implications of having all these intelligent agents managing our networks? I mean, this is critical infrastructure we're talking about. It's a lot to think about, right? But we'll be back in part two to explore even more of these cutting-edge 6G technologies. Stay tuned.
Welcome back. It's fantastic to have you back. I think we left off on a pretty exciting note.
Yeah, we were talking about all these amazing possibilities of 6G and AI, but I don't know, it all seemed a bit, like, theoretical.
Yeah, I can see that.
But one thing that really stood out was that study they mentioned, the one that actually tested these AI agents in a real-world scenario.
Ah, yes. You're talking about the vehicle to everything, or V2X communication study.
Exactly. Cars talking to each other, talking to the infrastructure, basically creating this whole network on wheels to make driving safer and more efficient.
Right. And it's really a perfect testing ground for this kind of AI because you need super fast, reliable communication in an environment that's constantly changing.
Yeah, makes sense. So how did those AI agents do in this real-world test? Did they live up to the hype?
The results were pretty impressive, actually. The study found that AI agents just blew traditional methods out of the water across the board. For example, they achieved a way higher packet delivery ratio, meaning more data got where it needed to go more reliably and quickly.
Okay, so like crucial messages, things about braking, hazards, stuff like that, those are much more likely to get through without any problems.
Exactly. And in a V2X scenario, even a tiny delay could have huge consequences, so reliability is key. And the paper also mentioned that AI agents improved link robustness.
Oh yeah, link robustness. What did that mean again?
Well, in this context, it means maintaining a strong, stable connection, even when you're in areas with lots of interference, like tunnels or, really dense cities.
So even if you're driving in a tunnel surrounded by buildings, the AI can still keep the network going? That's pretty amazing.
It is. And they also managed to cut down on the retransmission rate, so fewer messages had to be resent because of errors. It makes the network much more efficient.
Okay, so the AI agents are definitely pulling their weight, it seems, in terms of performance and reliability. But what about adaptability? Like, can they really handle the sudden changes that happen all the time when you're driving?
That's one of the things they tested in this study. And the AI agents were just way more adaptable than conventional methods. They could adjust to all these changes on the fly and make sure the user had a seamless experience.
So, like, if you're driving and it suddenly starts pouring, or you're going through a busy intersection, the AI can just reconfigure everything in real time to keep things running smoothly.
Exactly. And remember, we talked about latency earlier, that delay between sending and receiving data? Well,
Mm.
in this study, the AI agents had significantly lower latency compared to those traditional methods, which is super important for things like self-driving cars.
It's kind of wild to think about these tiny AI agents making such a big difference in something as complex as driving.
It is, and this is really just the beginning. I mean, this study focused on V2X, but it shows the potential of this kind of AI to completely change how we interact with tech in all parts of our lives.
It really makes you think about all the possibilities. So as we wrap up this deep dive into 6G, what's the one big thing you want our listeners to take away from all of this?
I think the most important thing to understand is that 6G is not just some incremental upgrade from 5G.
Hmm.
It's a total shift in how we think about and design these networks. It's about going way beyond speed and creating a future where networks are intelligent, adaptable, and, able to handle all these new things that we haven't even thought of yet.
And AI,
Mhm.
especially this agentic AI, is right at the heart of all of that. We've seen how these AI agents can make things faster, more secure, and create this more resilient infrastructure.
Exactly. And that V2X study we talked about, it shows that this isn't just some far off dream, it's actually happening.
So all our listeners out there, get ready for a future where communication is smarter, faster, and way more seamless than ever before. Thanks for joining us on this incredible deep dive into the world of 6G.
Okay, so we've covered a lot of ground talking about AI and 6G, but it's all been, pretty theoretical up to this point.
Yeah, I see what you mean.
What I found really fascinating was that study mentioned in the paper, the one where they actually put those AI agents to the test, like in the real world.
Right, the vehicle to everything, or V2X communication study.
Exactly, where
Wow.
cars are communicating with each other and the infrastructure around them, like creating a network on wheels.
It's a great example of where this technology could really make a difference, making driving safer and more efficient, for sure. So, like, how did those AI agents actually perform in the real world? Did they live up to all the hype?
Well, the results of that study were pretty remarkable. They found that the AI agents significantly outperformed traditional methods in, well, pretty much every category. For instance, they achieved a much higher packet delivery ratio, meaning more data got where it needed to go reliably and quickly.
Okay, so that means that those important messages, about sudden braking or hazards or whatever, those are way more likely to get through without any problems.
Exactly. And in a V2X scenario, even a tiny delay could have serious consequences, so that reliability is absolutely critical. And the paper also mentioned that AI agents improved link robustness,
Oh, yeah, link robustness. Remind me what that is again?
it refers to maintaining a strong, stable connection even when you're driving through areas that have a lot of interference, like tunnels or those dense urban environments with lots of tall buildings.
So even if you're like surrounded by buildings or driving underground, the AI can keep that V2X network going strong.
That's incredible. It really is. And they also managed to reduce the retransmission rate. So fewer messages had to be resent due to errors, making the network much more efficient overall.
That makes sense. Okay, so these AI agents are definitely proving themselves when it comes to performance and reliability. What about adaptability, though? Can they handle all the sudden changes that you get when you're driving?
Well, that was one of the key things they were looking at in the study. And yeah, the AI agents were much more adaptable than traditional methods. They could basically adjust to all those changing conditions on the fly, making sure the user had a seamless experience.
So, like, if you're driving along and it suddenly starts raining really hard or you're approaching a really busy intersection, the AI can just reconfigure the network in real time to keep everything running smoothly.
Exactly. And if you remember our discussion about latency earlier, that delay between sending and receiving data, well, the AI agents in this study delivered significantly lower latency compared to conventional methods, which is absolutely crucial for real-time applications like, self-driving cars and stuff.
It's pretty mind-blowing to think about these tiny little AI agents making such a huge impact on something as complex and important as driving.
It really is. And this is really just the tip of the iceberg. While this study focused on V2X communication, it really highlights the massive potential for agentic AI to change how we interact with technology, like in every aspect of our
It
lives.
really makes you excited to see what the future holds. So, as we wrap up this deep dive into the world of 6G and AI, what's the big takeaway? What do you want listeners to remember from all of this?
I think the key thing to remember is that 6G isn't just some kind of minor upgrade over 5G. It's a completely different way of thinking about and designing communication networks. It's about moving beyond just speed and creating a future where networks are intelligent and adaptable, networks that can support all these incredible new applications we can't even imagine yet.
And at the core of it all is AI, right?
Mm,
Specifically, agentic AI. We've seen how these AI agents can optimize performance, improve security, and create a much more decentralized and resilient infrastructure. And it's not just a pipe dream.
yeah, it's not science fiction anymore. We're seeing real world proof that this stuff is actually happening.
So to all our listeners out there, buckle up. Get ready for a future where communication is smarter, faster, and more seamless than ever before. Thanks for joining us for this incredible deep dive into the world of 6G.